So these numbers we are calling as surds. It is just any number that doesn't have a perfect square inside and you've got a root. Okay, those are what we call surds. An example that I'm going to refer to is if you talk of a square root of 2, you know 2 is not a perfect square number, right? Because if you say square root of 2, you'll not get a whole number. I'll talk of the square root of, let's say, 3, the square root of 5, because square root of 4 is going to give you a 2, meaning that it is not a surd, right? So it's not a surd. Surds are only those numbers which, when you perform a root, they are going to give you what? They are going to give you a decimal, like square root of 6. So you just think of any number that is not a perfect square, then that number is going to be what? That number is going to be a surd, right? For example, square root of 7, like that. So it is important for us to know how to add surds and also how to subtract surds. Now the question is, how do we add and subtract surds? So when you are subtracting or adding surds, you need to make sure that what is inside the decimal point, inside the root, it should always be the same. Okay, it should always be the same. For example, if I've got the square root inside, let's say I've got a 2, for me to add it to or subtract it to another thing, inside there should also be a square root of 2. Okay, like that. Let's say this is what I have, square root of 2 plus square root of 2. So how do you add? You are just going to look for the numbers that are in front of the root here. These numbers in front. Although you are not able to see them, but we know that there are ones in front of those two roots. So we're going to get this one and this one. You are going to add them. That is going to give you 2, and then you just write the square root of 2 like that. Okay. So apart from that, let's say if you have 3, okay, if you have got 3 square root of, let me say 3 square root of 3, and then minus 5 square root of 3. Now I want to subtract these two numbers. The question is, how can you do it? So always you just get those numbers that you are seeing outside, right? Since what is inside is the same. So we're going to get the 3 minus, get this one which is outside, which is the 5, like that. And then I'm just going to put square root of 3 this side. So 3 minus 5, that is a negative 2, right? And then square root of 3. So this is the answer when you subtract those. What if you have got, let's say, 2 square root of 7 plus, let's say, 7 square root of 7, then minus 3 square root of 7. How can you do this one? So to work it out, just get the numbers which are outside. You've got a 2. I'm going to write it. And then I've got this positive 7. I'm also going to write it. I've got this negative 3. I'm also going to write it. And then I'm going to put that in a square root of 7. So this is going to be 2 plus 7, which is a what? A 9. 9 minus a 3, which is a 6. So it will be 6 and then square root of 7. So this is how you add and subtract surds. Okay, before I do some other examples introducing another thing, are we good? Does anyone have a question? Or we are good? Do we have anyone having a question?
Me, I'm good.
Okay, what of Naomi? Are you good?
I'm good.
Great. All right. What of Chawezi? All good? Okay, great. Now, at times, these size that we're able to see here, you might not have the same thing inside, but you want to add and subtract them. Question is, how can you do it? For example, they've given you square root of 2. Let me say square root of 3 minus square root of 12. Okay, you want to add these two or subtract these two. All right, square root of 3 minus square root of 12, you want to subtract them. So the question is, how can you subtract them? So the first thing is, you always need to make sure that what is inside the roots is always the same. Now remember, at the beginning I wrote perfect squares. Perfect squares, we've got 1, okay, we have got 4, we have got 9, we have got 16, we have got 25, we've got 36. These are numbers that you can square root and do not get a decimal. We call them perfect squares. So I'm going to look at the smallest number. So forget about 1, because 1 into anything is that same thing, right? So I'm going to look at the smallest perfect square. This is, in this case, a 4. So I'm going to say, can 4 go into 12? If it does, okay, that is good. So I'm going to write this as square root of 3 minus square root. So 12 is the same as 4 multiplied by 3. Okay, so this is going to give us square root of 3 minus. When you have got things inside a root multiplying, you can split them. So I'm going to have square root of 4 times square root of 3, like that. Okay, these, remember, they are together. So this is going to give us square root of 3 minus. You know what is the square root of 4? What's the square root of 4?
Two.
It's a 2.
Two.
Good. It's a 2, yes. So I'm going to write that 2. Remember, this has given us 2, but we also have the square root of 3 here. So that will be 2 square root of 3. Now we can subtract, since we now have the same thing inside. All right, we have got the same thing inside the root. So we get the number that is in front here. Of course, we know that is a 1. And then we get the number that is in front here. That is a negative 2. Okay, like that. And then we're going to just get the square root of 3, like that. So 1 minus 2 is a negative 1. So I'll write a negative, and then I write square root of 3. Like, you don't show a 1. I can't write negative 1 and then square root of 3. You don't write a 1 in front of anything. Just like x, we know that there is a 1 in front. Okay, so we don't write that. Alright, so is this okay? Or there is anyone who has got a question somewhere? Is this okay?
For me, it's okay.
Alright, good. Please be so free to ask if you've got a question. So this is how you get to work out those surds which involve subtraction and addition. Let me just make it even a bit more interesting. Let's say we have got square root of 72. Okay, let's say plus, what can I even put, plus the square root of 32, and then minus, you can say, let me think of a nice number. Okay, we can say square root of 200. Alright, so this is what we have. We want to work out these questions we're able to see. Okay, this question, add or subtract square root of 72 plus square root of 32 minus 200. So what we are going to do is try to divide by the smallest number. Look, the smallest number in this case I'm talking about, you have got one number like 1, 2, 3, 4, like that. So forget about 1, because 1 into anything is just itself, right? So start dividing by the smallest number, and make sure that when you divide, you should get a perfect square number. So we are going to say 2 into 72. Why have I gone to 2? Because if I say 1 into 72, we know that to be 72, right? So I'll say 2 into 72. We know that is going to give us what? 36. So you ask yourself, is 36 a perfect square number? Who can answer us? Is 36 a perfect square number or not?
Yes, 36.
Good. It is a perfect square
Yes,
number.
36.
Great, great Lenge.
Yeah.
So we're going to write this as a square root, where the 72, we write it as 36 times 2, alright? And then we say plus. We also go to 32. 2 into 32 is what? 16. Is it a perfect square number or not? It is. So we're also going to write that 16 multiplied by 2. And then minus, we go to the 200. 2 into 200, we know that is 100, right? So that is going to be 100 times 200. We know that 100 is a perfect square number. So we'll just say the square root of 36, we know that is a 6, right? So we're going to say 6, and then will remain with the square root of 2. Why have I done this? Because we know that we can split this into square root of 36 and then times the square root of 2. So even if I've not put a times, I've just written like this, it means there is a times there, right? And this square root of 36 is what has given us this 6, which is here. So basically that is what I've done. And then plus, we also come a square root of 16, we know that is a 4. And then I write a square root of 2, which has remained. And then square root of 100, we know that is a 10. And then I'm going to write square root of 2, which has remained. Okay? Now we'll add, since we have the same thing inside. So I'm going to get a 6, which is outside. I'm going to get a positive 4, which is outside. I'm going to get a negative 10, which is outside. And then I write the square root of 2. So 6 plus 4, we know that is a what? Is a 10. Minus 10, that is a 0. So this is going to be 0 square root of 2. And you know 0 multiplied by anything is always 0. That means this is going to give us a 0. If you have got your calculator, try square root of 72 plus square root of 32 minus square root of 200. It will give you 0. So this is how you work it out. So if it didn't give us a 0, for example, if it gave us a 3, so the answer would just be 3 square root of 2. Alright. Any question? Are we good? We are good?
Yes, we are good.
Alright. Now, since we've understood how to add and subtract, let's understand also how to multiply and then divide. Then this topic is done. And trust me, it will always be there in the exam. Actually, in your test 1, it is going to be there. Even in your quiz 1, it is going to be there. Alright, how to multiply surds. So just the same way we multiply uh, in algebra, this is also how we multiply surds. For example, if you have got a square root of 2 plus 1, okay, you want to multiply this by, let's say, the square root of 2 minus 3. To multiply this, get this first one, multiply with this one. That is going to give you square root of 2, another square root of 2, because we're multiplying two square roots of 2's, right? And then get a square root of 2, multiply by this one. Okay, that is going to give us, I'm going to get this negative 3. Okay, and it is multiplying with what? It is multiplying a square root of 2, if you can see, right? If I'm done with that one and then I go to the 1 times square root of 2, it is going to be square root of 2. And then 1 times negative 3, that is going to be negative 3. Now, square root of 2 times square root of 2. You need to know that if you have got square root of a times square root of a, this is going to give you a. The reason is simple. Square root of a times square root of a, you are going to get these things which are inside, you multiply them. That will give you square root of a squared. And this square and the square root, they cancel. That's why you find a. Like if you say 2 times 2, that will give you a 4. And you know square root of 4 is a 2. That is why we are saying when you're multiplying the same thing, you always get that same number that you are multiplying. Alright? Are we good? Are we good?
Yeah, just a bit. Someone disturbed me.
Okay.
Uh, on
Okay.
how to multiply.
Okay, so you just do the same way we get to multiply when you're talking about algebra. You get the first one here, you multiply with the first one here, and then you get the same first one, you multiply by the second one here. After you are done, get now the second one, multiply by the first one, and then this second one multiply by the second one there. Is that okay?
Yes, yes.
Alright. Now from here, you add like terms. So we're going to get these 2 and this negative 3. So 2 minus 3, that's a negative 1. And then we get this negative 3 square root of 2 and this 2. What do you think? I want someone to tell me what is going to be the answer if we say negative 3 square root of 2 plus square root of 2. What is going to be the answer? Anyone?
Negative 2 square root of 2.
Good. Very good. It will be negative 2 square root of 2. The reason is simple because this is a negative 3. You get a plus 1 which is in front of here. Negative 3 plus 1, that's a negative 2. Alright, so this is going to be the answer. Actually, you are going to see they are going to ask you that leave your answer in the form a plus b square root of c. So actually this answer that you have seen, we have left it in this form. This is how questions are going to come, leaving your answer in the form a plus b square root of c. So that means that the negative 1 here is the a, okay, negative 2 is the b, and then the 2 which is inside is the c, okay. So we have left in the form that they've asked us. All right, I'm hoping this is okay. Do you have a question before we do another question? Any question before we answer other questions? Okay, are we good?
Yes, we can proceed.
All right. So let's say we've been asked to multiply. Let's say we have got 4 square root of 3 minus 2, and then times, let's say we've got 3 plus 2 square root of 3. And the question is saying leave your answer in the form a plus b square root of c. Okay, that's the form that we want to leave the answer. So what are we going to do? Get the first one here, multiply with the first one here. Now you need to know that this number, if a number is not in the root, it will always multiply the number that is in front here, not the one that is inside, okay? So this 3 in this bracket is not in a root. So it's going to multiply this number which is in front. So it should never multiply what is inside. So that is going to give us a 12, and then we're going to have square root of 3, right? And then I'm going to get this multiplied by this. So again, what is not in the roots, they multiply each other, and what is in the roots, they also multiply each other. So this is going to be 4 times 2, which is 8, right? That is going to be 8. And then square root of 3 times square root of 3. What are we going to get? Square root of 3 times square root of 3. Anyone?
We're going to get 3.
We are going to get a 3, because if you multiply the 3 and the 3 inside, that will give you a 9, and square root of a 9 is a 3. So I'm going to write a 3 like that. Remember, these two are supposed to be multiplying, alright, because this is connected and these are also connected, so those are supposed to multiply. When you are done with that, now you come to this one, negative 2 times 3, that's a negative 6. Then negative 2 times 2 square root of 3, this negative 2 is supposed to multiply with this 2 which is outside, right? So that is going to give us negative 4, and then we've got a square root of 3. So all we do is we're going to pair up like terms. 3 times 8, that is a 24, right? And then we're going to put a minus 6 as like terms. And then we're going to write the 12 square root of 3, and then write the negative 4 square root of 3. So 24 minus 6 is that an 18, and then 12 minus 4, that is an 8. Okay, and then square root of 3. So we have found the answer in the form a plus b square root of c. So this is how you get to leave it. I'm hoping it is okay. Please, if it is not, get to ask questions. Are we good?
Yes.
Alright, so this is how you multiply. Now the last part is how do you divide surds? Division of surds. Okay, so when it comes to the division of surds, for example, when if you've got something, you need to know the principle behind something when you are getting to do the division. When you have got, for example, a number, okay, like any number on top over a square root, okay, over a side, maybe square root of a. To divide this, what you are going to do is the same thing that you are able to sit down, you are going to multiply on top by square root of a, even down by square root of a. If you do that, what you're going to see is this 1 times square root of a, that is going to give you square root of a. And then down, square root of a times square root of a, what are we going to get? Square root of a times square root of a. Is that not going to give us an a? Okay, if you multiply the same thing that is inside the radical, you just get that same thing. Like a times a, that would be a squared, and square root of a squared, the a, the squared and the root, they are going to cancel themselves. Okay, are we good? Do we get that?
Yes.
All right. So if we have now something like this, so my interest is not on top, my interest is in the denominator. If you have got, let's say, the square root of a number, let's say this is a number a, and then plus a constant like that. To divide this, what you do is you are going to look at the denominator. That same thing that is in the denominator, you are going to write it on top, but you change the sign between, okay? You also write it down. You are going to change the sign between. So always get the one which is down and change its sign. So we call these two as conjugates of each other. Why? Because they are only different by a negative. They are almost the same, but one is negative, one is positive. So basically, if I multiply a surd by its conjugate, what I'm doing is rationalizing the denominator. Rationalizing the denominator. So what we're going to do is we're going to multiply this one by these things which are on top. We know we're going to get the same thing, square root of a minus b. And then if we multiply a surd by its conjugate. Now, do you remember the difference of two squares in high school? A plus b, a minus b. Difference of two squares means what you had was a squared minus b squared. I don't know if you remember this, do we?
Yes, we can.
Okay, good. So you can see that this and this is the same as this one. We've got one with a positive, one with a negative. That means how it was is you had the first one squared and then the second one squared, and then there was a minus between them. In other words, if you want you can do the multiplication as we did. You get a square root of a times a, square root of a times b, and then b times this one, and then b times that one. But that's a waste of time. Like in the exam, you not have time or in a test. So what you do is just get the first number, you square it. Okay, that is going to be square root of a, you square it. Always get a minus, please, always. Even if this one was a minus and then this one is a plus, always get a minus, because there will still be difference of two squares. And then get the second thing, which is here, and then square it. Okay, so this is how you work out. So what we've done is rationalize the denominator, so we can now use questions to see what we are talking about. For example, they want us to express, let's say we have got the question, express the following in the form a over b. Okay, sorry, not in the form a over b, I'm thinking of another, in the form a plus b square root of c. Okay, in that form. And the first one we've been given, let's say we have 2 plus square root of 3 over square root of 2. Okay, you want to express this in that form that you've been given there. Let me say over square root of 3. Now the question is, how do you express in that form? How do you express in that form that you've been given? So what you are going to do is just look at the denominator which you have. Okay, the same, if you don't have an addition or subtraction in the denominator, just get this thing which is in the root. Okay, the root 3, you multiply on top by root 3, multiply also down by root 3, and this is going to give you, you are going to have 2 times root 3, that is going to be 2 root 3. Then you are going to have root 3 times root 3, remember that is just going to give us a 3. And then in the denominator you are going to have 4 root 3 times root 3, that will simply be what? 4. Okay, like this 4 with the number in front, to multiply with the number that is in front here, which is a 1, though we can't see it. And then these which are inside, they're also going to multiply. Now square root of 3 times square root of 3, that will just give us a 3. Okay, like that. And then from here, what we're going to do is going to give us 2 square root of 3 plus 3 divided by what? By 12. Now we are going to split the 12, so the 12 is going to be common, so that will be 2 square root of 3 over 12, and then plus 3 also over 12. You just split like that. Now a 2 can go into 12, that is 6 times, so that will be square root of 3 over 6. And then a 3 can go into 12, that is 4 times, so that will be 1 over 4. Now since we want a, that means a number without a root to be the first, so I'm going to start with 1 over 4, and then I'm going to write, now square root of 3 over 6 can also be written as 1 over 6, and then I write square root of 3. Why? Because square root of 3 can multiply with the 1, it will still give us what is on top. So we have expressed in the form that they want, a plus b square root of c. Alright, any question? Any question? Alright, we are good.
Yeah, for me, no question.
Okay, now any question?
No, I don't have any question.
Alright, good. uh um what of Chichi, let me call you like that. Any question? Alright, now the same question. Now let's say we've been given 2 minus 3 square root of 2 divided by, let's say we have 4 minus, let's say 4 square root of 2. This is the equation that they want us to express in the form a over b. Now for this one, since we have got an addition, a subtraction in the denominator, What are we going to do? We multiply by the conjugate. The conjugate of what we are seeing down, we just change the sign. Please, you always multiply by the conjugate of the one down. Always the one down, not the one on top. So that will be 4 plus 4 square root of 2 over 4 plus 4 square root of 2. Okay? Then we start multiplying this 2 times this 4. That is going to give us 8. This 2 times this 4 again, that is going to give us 8, but remember there is a square root of 2 there. And then this negative 3 times the 4, that will be negative 12, but remember there is a square root of 2 there. Negative 3 square root of 2 times 4 square root of 2, multiply what is outside, the negative 3 and the 4, it is going to give us a negative 12. Multiply the inside, root 2 and root 2, we know that is going to give us a 2, right? And then in the denominator I'm multiplying a number by its conjugate, so just get the first number, you square it. Okay, and then always put a minus, always. And then get the second number, which is the 4 square root of 2, you also square it. So this is going to give us 12 times 2, we know that is a 24, so that will be negative 12, 24, like terms with this one. So that will be 8 minus 24. Okay, and then we have got this and this, these are also like terms. That will be plus 8 square root of 2 minus 12 square root of 2. In the denominator, 4 squared, we know that is 16, minus this 4 squared, that is a 16, and then the root of 2 squared, that will just be a 2, because the root and the 2, they what, uh, they cancelled. Sorry, I've noticed that I'm faster than the sound. I just hope you get to see what is happening. Okay, it's there. I don't know if it is okay, or I should repeat. I Can you connect what I've said with what you're able to see?
You just repeat a bit.
Okay, so what basically we are saying is this 12 times 2, that gave us a 24. Negative 24 is the one that you're able to see here. So I brought it near 8 because they're going to be like terms. They don't have a root, both of them. And then this 8 root 2 is the one I've put here. Negative 12 root 2, that's the one I've put here because they are like terms also. And then in the denominator I've got 4 squared, which is a 16. And then we have got this 4, which will give us 16. Then we have got this root 2 squared, that will just give us a 2 because the square and the root will cancel. So this square is applying both to 4 and to root 2. So that is why we have got all these numbers. Are we good?
Yes.
Alright, now we do the subtraction. 8 minus 24, what value do we get? Is it a 16, negative 16? And then 8 square root of 2 minus 12 square root of 2, that would be negative 4 square root of 2. And then in the denominator, 16 times 2, that is a 32. So it will be 16 minus 32. We know that is still negative 16, alright? So we can now split. This is going to be negative 16 over negative 16 minus 4 square root of 2 over negative 16. So these two are going to give us a 1, right? This negative and this negative will give us a positive. 4 into 4, that is a 1. 4 into 16, that is a 4. And then we've got a square root of 2 that has remained. So what we've done is rationalize the denominator, and we've expressed it in the form a plus b square root of c. Okay, are we good? Are we good? I'm just remaining with two questions for practice, and then we are done completely with the topic.
Me, I'm good.
Great. I'm hoping Tina and Nam, we are also good. So we also want to rationalize or to express in the form a plus b square root of c. We have got, let's say, a 2 divided by square root of 12 minus square root of 32 plus square root of 72. Okay, this is the question that we have. We want to express in that form. And then let's say plus a 4. Okay, this is the question. So the first thing is we look at the denominator. We need to simplify the denominator. So this is going to be 2 over. We know square root of 12 is the same as square root of 4 times 3, right? What of square root of 32? How many times can 2 go into 32? That is 16, isn't it?
16.
Actually, let me not even use a 12 here, because a 12 is not going to work out for what I want. Let me use 50. Please just change that. Let me use 50. So we will be dividing everything by a 2. So 50 is the same as 25 times 2. 32 is the same as 16 times 2. What of 72 is the same as what? Is it 36 times 2? And then we have got a 4 at the end. So this is going to give us 2 divided by square root of 25 is a 5, and then we have got square root of 2. Square root of 16 is a 4, and then we have got square root of 2. Square root of 36 is a 6, and then we've got square root of 2, and then plus a 4. So what we do here is add like terms. So I'll start first by writing the constant, which is a 4. It's the same thing. And then I'll say 5 minus 4, we know that is a 1, right? Plus a 6, we know that is a 7. So that is going to be positive 7, and then square root of 2. And then from this point, that's when we can conjugate. So multiply on top by 4 minus 2, 4 minus 7 square root of 2, also down by 4 minus 7 square root of 2. So this 2 times this 4, that gives us 8. And then the 2 times negative 7, that gives us negative 14 square root of 2. The denominator, remember, those are conjugates of each other. Get the first one, square it, minus. Get the second one, also square it. So this will give us 8 minus 14 square root of 2 over 4 squared is a 16 minus, 7 squared is a 49, right? And then we've got square root of 2 squared, which is just a 2, right? So this gives us 8 minus 14 square root of 2 over 16 minus, what is 49 times 2? Am I correct? It's 98. Yes.
Yes, it's 28.
Okay, thank you so much. So this will give us 8 minus 14 square root of 2 over, what is 16 minus 98? It's a negative what? Negative 82. Am I correct?
Yes.
Alright.
Yes.
And then from here we can split. So this is going to be 8 divided by negative 82 minus 14 over negative 82, and then we've got a square root of 2. So from here, look for a number that can go into 8 and 32. What number is that? Which can go into 8 and into 32? So basically this I'm going to write, instead of me having this negative down here, that would be negative 8 over 82. This negative here and this negative gives us a positive, to be positive 14 over 82, and then square root of 2. Please, I'll leave it here. I'll ask you to look for a number that can go into 8 and 82 without leaving a remainder, so that you reduce this fraction. And also look for a number that can go into 82 and 14 without leaving a remainder, so that you reduce also that fraction, right? Now let me look at the last question. And I think it's one of the trickiest I've come. close to so far. You want, now this one is not even to express in the form a plus bi, but rationalize the denominator. Okay, like the question which I saw in last year's paper for one school, rationalize the denominator. Now the question is 1 over square root of 2 plus square root of 3 minus 1. Okay, this is the question. We want to rationalize the denominator. Now, do you think there's anything that we can do so that one of this is going to be the same like the other? For example, we just have a constant and then square root of a number. Do you think there's anything that we can do to 2 or to root 3 or to 1 so that we add them or subtract them? Anyone? So I barely think so. There's nothing that we can do. Like for the previous ones, we could say, okay, for 12, we know that 3 times 4 is a 12, so we can express 12 in this form. But these are already simplest forms. So what you are going to do is, I'm going to remain with only one root, okay? Only one root. And then the other one which remains, so that means this second portion which remains, I'll just get any letter. So I'm going to say let, okay, let me say let x be equal to square root of 3 minus 1. Okay, so this gives us 1 over square root of 2, and then I'm getting this, there is a plus there, so where there was square root of 3 minus x minus 1, I'm putting an x there. Are we good here? Are we good?
No, I'm left behind.
Okay, so when you are dealing with the one which has got 3 terms like this one, what you do is just leave one root, okay? Leave one root, and then what remains, so this one which remains here, the square root of 3 minus 1, just let any letter of your choice represent that part, because you know you can only rationalize things when there are the two of them, but here there are more than two. So where there is the square root of 3 minus 1, we're going to put an x, so that we are going to remain with root 2 and only x. So we're going to have the two of them, and it will be easy to rationalize. So this would be 1 over square root of 2 plus, where there was root 3 minus 1, we put an x there. So the whole of this portion where there was root 3 minus 1, remember we said 3 minus 1 should be equal to x. So I've put x there. Are we good? And then now we conjugate, multiply on top by root 2, but change the sign, remember that's how you conjugate, and then down also by root 2 minus x, right? So 1 times root 2 minus x, that will just be root 2 minus x. In the denominator, square root of 2, now remember these two are conjugates, so just get the first one, square root of 2, you square it, and then minus, always get the second one which is x, you square it, right? So this is going to give us square root of 2 minus x over square root of 2 squared is a 4 minus x squared. But I'll get, instead of me having this x squared, I'll say where there is x, I substitute square root of 2 minus square root of 3 minus 1, because that's what we had said was x, but remember it was x squared, so this will be squared. Are we moving together? Are we moving together? Naomi, are we okay?
Yes, I'm okay.
Okay, Tina and our other friend.
Yes, we can continue.
All right, so this continues. We are going to have square root of 2 minus x over the 4 here, okay, minus. Now, what we are going to have here is 3 minus 1 squared. Square root of 3 minus 1 squared. You can write it 2 times. Square root of 3 minus 1 multiply by square root of 3 minus 1, and then start crossing and multiplying. So what we get is square root of 3 times square root of 3, which is a 3. Okay, minus 2 square root of 3, then plus a 1. I've just done them direct, like everything together. If you want, you can go by them. You do this, you do that, and then you do this, and then you do that. You are going to find what I found. And then now you can add like terms. You've got this 3 and this one, that will give you a 4, then minus 2 square root of 3. So that's what we're going to get here, 4 minus 2 square root of 3. And this is going to give us square root of 2, okay, minus x over. You have got this 4 minus 4. We know that is a 0, right? Okay, and then this negative times this negative, that is going to be positive 2 square root of 3. Now that we are at this point, now we can rationalize even easily. So I multiply on top by square root of 3, even down by square root of 3. So this square root of 2 times square root of 3, just multiply what is inside, right? That is going to give us square root of 6. And then negative x times the 3, that will be negative x square root of 3, right? And then the two denominators, multiply them. Square root of 3 times square root of 3, that is a 3, right? But remember, also have a 2 in front, so that will be 3 times 2, which is a 6. So what we've done is rationalize the denominator. You can see we don't have a side in the denominator, so that is it.